Hello! Welcome back to computer science, and welcome to the exciting world of Python strings. It's the moment you've all been waiting for. All right, so most of the programming that we've been doing has obviously involved images and image modification. But I don't think it should come as any surprise that there's more to programming than just modifying pictures. So what we're going to look at today is strings. So sequences of characters and how we can use Python to manipulate it, do things with text, go through text, look for things in text, modify text, all sorts of things that revolve around text. All right, so that's kind of the big topic for today. And chapter 3 of your Python textbook is where most of this material is coming from. Okay, so let's go back to some of the basics, and some of this we've seen before. But a string is a sequence of characters. In Python, a string is defined inside of quotation marks. So here's me creating a variable name and storing in that a string that has the letters M-A-R-K. Here's me creating a variable dog and storing in Rover. So you can print out strings, and because it's the variable, you wouldn't need to have the quotes around it there, and it would just print out the word Mark. And you can concatenate strings, which means to kind of combine them. So this is combining strings with variables, and we can concatenate things in Python. So this would say, I am Mark, and my pet's name is Rover. All right. We can also get the length of strings. All right. Length is a function built into Python, and it will automatically tell us the length of the string or how many characters are included in that string. Now, one thing we have to remember is that the space is a character. So if we were to run length on this string right here, it would actually be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this would print out the number 10. All right, so these are just some of the very, very basics when we're dealing with this. Okay. So let's take a look at some more things that we can do and kind of how it's going to work when we've got variables and everything else going on here. So here in a variable, we're putting the word great, and then notice that there is a space after the T there, and that space is part of our string. And then in the variable b, we have the word grandmother, and notice that there's no space inside of that. All right, so if we were to say print a plus b, take a second, write down what you think that would be. All right. And hopefully you realize, because this is something we did at the very beginning, that it's going to basically stick those strings together. So we would end up with great with a space, great with another space, and then the word grandmother. All right. Then down here we have line C equals A plus A. So this is creating a new string variable called C. And inside of that is going to be A plus A. So when we print out C, it's now going to have great space, great space. And we might not actually even notice that second space when it prints out to the screen, but it is important to know that it is there and it is part of that variable and it's being stored in that variable. All right. So when we do C equals C plus C, we're basically saying great, great plus great, great. So if we print out our new C, it's now going to be great with a space. It's going to be great with a space. And again, because that space is there, there is still going to be that space between the next great with a space and then a great and a final space there, even though technically we're not going to see it when it prints out to the screen. It is there. It is being stored in C, which is why if we print out the length of C, it's going to be 6, 12, 18, 24. All right, so again, we might not notice it when we visually look at it, but it is stored in that variable The computer doesn't really care that it's a space. To them, it's just another ASCII code that it has to store to represent the character. All right, and then we also saw that we could use multiplication with strings. So if we do multiply by A is still just great. So this would print out great, great, great. So again, this is all stuff that we looked at when we first started Python, but it's good to kind of refresh it before we go into some of the new stuff that we're going to look at today. All right, so what is this new stuff? All right, the new stuff is using loops to work our way through a string. All right, because you can think of a string as basically just a list of letters. All right, so instead of letters, I'm actually going to say a list of characters, right? Because it doesn't have to be a letter. So it's a list of characters. And we can go through that list one by one by one by one. So we have this loop here for letter. Now, again, letter is just our loop variable, all right? There's nothing special about me using the word letter there. That's just the name that I've given my loop variable. In string, and again, string is not anything special. It's the parameter that was passed into the function. So the fact that I'm using the word string here, it could have been anything. It's based on the parameter that we have here. So this is my list. So this loop is going to go through and it's just going to take on each value in that list. So you can read it as for each. So for each letter in the string, we're just printing the letter. So this loop is just going to go through it one at a time and say, okay, first it's going to print out the H, then it's going to print out the E, then it's going to print out the L, the L, the O. And this is a typo on my notes. It wouldn't suddenly make that uppercase. It would, if the original string is lowercase, then this should also be lowercase. So I apologize for that, but just know that it wouldn't be uppercase. If the string is lowercase, it would print out as lowercase. Sorry about that. So yeah, you're just going through it one by one by one, the same way we would go through a picture. So we could go through a picture pixel by pixel by pixel by pixel and do something different to each pixel. We can do the same thing with a string. We can go through it letter by letter by letter using this format. For, and again, this is just the loop variable, could have been anything. I could have said for L, for Q, for banana in string. And again, this part could have been anything. It just happened to be the name of my variable. And then you can print or do whatever code you want inside of the actual loop. All right, so let's just take a closer look and really break down all the different parts of this. All right, so the word for is just part of the syntax. All right, that has to be there. It's part of Python. It always exists. Next comes the loop variable. All right, so you choose the loop variable. Right? It doesn't have to be letter. That is your choice of what you are defining as the loop variable. In has to be there. So that's part of the syntax. All right. And this is your list of characters, your list or string, and you choose the name of the variable. All right. And again, that's coming from here. So this one's called string because that's the parameter we passed in. But you as the programmer could pick what you want for that there. And then here we have the colon. That has to be there. That's what comes before the start of the body. And again, that's part of the syntax. It's just a required part of what it is. Notice that anything inside of the loop is still indented. All right, that's how we know that it's inside of the loop. All right, without the indent, it won't work correctly. And then what's inside of the loop is really up to you. I mean, that's the function of your program. Right now, we're just focusing on printing, but it could be anything inside of the loop. It's not like you can only print. You can do lots of things with this variable that, again, is just going to have whatever letter it's currently on as it works its way through the entire string. All right, so let's take a look at a couple of these and try to figure out what's going to happen. All right, so we've got function mystery 1 here. All right, this time instead of it being called string, the variable's name is text. All right, instead of us using the word letter, we're using a variable of C. So this is saying for each, C is probably like for character, for each character in the text, print C. So what is this going to do? Well, it tells us up here that we're calling it with the parameter snow. So snow is getting stored in text. We're going through that word snow one letter at a time. And then we're just printing out the letter. So we'd start with a capital S. And then because each print statement ends up on a new line, we'd go down to a lowercase n, a lowercase o, and a lowercase w. All right, so it's pretty much the same one that we just saw on the examples there. All right, so now let's take a look at mystery 2. And what I would encourage you to do is pause the video, try it, and then see how you did. All right, so mystery 2 text says for C in text. So same setup as before. We're going through the word one letter at a time, only this time we're printing C times 3. All right, now we saw with strings that if you multiply it by a number, it just prints out the string that many times. So C is originally just the letter S, so that's going to print out S, S, S. Then it moves to the next letter, which is a lowercase n. So then we're going to print out N, N, N. Then it moves to the next letter, which is O. So we're going to print out O, O, O. Then we're going to move to the last letter, which is the W. So it's going to print out lowercase w, lowercase w, lowercase w. So it's going to look like that. All right, let's move up to mystery 3. All right, what do we have here for mystery 3? So for mystery 3, num equals 1. So we have a new variable here. And then we say for C in text, print C times num equals num plus 1. All right, so a little more going on here, but let's see what we've got. All right, so we have this variable. It's set to 1 at the start. This says for C in text, so we're still going through the word snow one letter at a time, and it's saying print C times num. Well, the very first time through the loop, C, num is still going to be 1. So this is effectively saying print S times 1. All right, then num gets 1 bigger. So num gets 1 bigger. We go back to the top of the loop. Now we're on the letter N, and it's going to be N times 2 because num got 1 bigger. Then it's going to get 1 bigger again, so now it's going to be up to 3. We're going to go back to the loop, and it's going to do O times 3. And you can kind of see the pattern at this point, but it gets 1 bigger. It loops back up to the top. We get to letter W, and it's going to do W times 4. All right, so that's how the different pieces are changing. All right, we see the letter C keeps changing, and the number num keeps changing as well. What is that actually going to look like as output? Well, it means we're going to print out an S, then we're going to print out 2 N's, then we're going to print out 3 O's, then we're going to print out 4 W's. All right, so it creates this little kind of like triangle effect. All right, mystery 4. We start off with text equals text plus text. So we're combining the string and making a longer string. So text was originally snow, but when we add them together, it's going to become snow, snow. So that's our new string. That's the string that we're working through when we set up our loop. All right, so we're now going through each letter in this string. So when we print it out, we're going to get the uppercase S N-O-W, but we're not done because now our string has 4 more characters, and we get another uppercase S, a lowercase n, an O, and a W like that. All right, so S-N-O-W, S-N-O-W, right? Because we made a longer string with this very first line of code. So again, not that any of these programs are particularly useful, but they're just kind of showing you kind of what happens as you work through one of these loops and some of the different things you can do to manipulate pieces as you're inside of the loop. So what's something we can do that's a little more useful? Well, we might want to look through the string for specific things, specific letters, specific characters, so on and so forth. All right, so we can do that. All right, we can use the if statement that we've started to use to look for specific aspects of our string. So here we have a function called justValues. It's taking in a variable called string. And then we have this loop that we're getting used to seeing, 4-letter in string. So we're going to go through that word, or not necessarily word. We're going to go through that string 1 letter at a time. And then we have this new if statement here. It says if letter in A, E, I, O, U. So what this basically is going to do is this is going to be true if the letter is in the list. All right, so if the letter is in A, E, I, O, or U, or string, if the letter is in that string right there, A, E, I, O, or U, it is going to print the letter. Otherwise, it's not going to print anything. Now, what I want to specify there is that capitals are different characters. All right, so if you want to look for lowercase a and capital case A, you'd have to put both of those inside of your quotes here. If you wanted to look for lowercase e and capital E, you'd have to put both of those in there. This is only going to look for the lowercase letters. All right, so when we pass it this string, hello there, it's going to go through it one by one. It's going to be like, it's going to say H is not in this list, so it's not going to print it. Then it's going to be get to E. It's going to be like, oh yeah, E's in the list, so it's going to print it. L and L it's going to ignore. O it's going to print. The space is going to get ignored. TH will get ignored. E will get printed because it's in the list. R will get ignored. E will get printed because it's in the list. The exclamation point will get ignored. All right, so we can add these if statements to start looking for different things inside of our strings and then carry out some action. Again, it doesn't just have to be printing, but it does allow us to kind of be a little more targeted with what we do inside of our loop. The loop is going to go through every single letter, but now we can target it and only have it do and make changes to certain letters. So this is how we can use if to sort of check for something. Now, if there's a whole lot of things that you want to check for, it can sometimes be easier to do the reverse. All right, so instead of having to make a big list of 30 different things, we can instead use the word not. Right? And if we say if not letter in, so pretty much the exact same thing we had before, except we're putting it inside of a not. So we've got not, left parenthesis, right parenthesis. Otherwise, it's exactly the same. And this is true if the letter is not in the list. All right, so same general idea, but you can sort of flip it around and make your life easier. So on this, it'll print out the H, it'll skip the E, print out the 2 L's, skip the O. Notice that it does print out the space. All right, the space is still a character, and it's not one of these characters, so the space still gets printed out, the T, the H, the R get printed out, and the exclamation point gets printed out. So again, when you're kind of trying to assess how these work, don't forget your space, because that is a character. All right, to a computer, it's no different than any other character. It has an ASCII code. It's going to interpret it just like anything else. So remember that it doesn't disappear. Okay? So let's do a practice here with some of this stuff and see what we can come up with. All right, so it says write a function called print s's text that prints out each occurrence of a lowercase s or an uppercase s in the input string text. For example, if the text is she's selling seashells, then the function should print the letters uppercase s, lowercase s, lowercase s, lowercase s, lowercase s, lowercase s. All right, so we're going to write a little function that carries out this description. So whenever we make a function, we start with the word def. So we're defining our function. The problem tells us what the function's name is going to be. So we're going to call it print uppercase s, lowercase s. It tells us that our input variable or our parameter there is going to be called text. All right. Anytime we do a function, we need to have our colon at the end of it. And then we're going to indent. All right. So we're going to go through the entire string. So if we're going to go through the entire string, we're going to start with our for loop. So we go for. Now, the next part is our loop variable. It can be called whatever you want, but I'm going to stick with this idea of using the variable name letter. Again, it doesn't have to be letter, but that's what I'm going to use. In is part of the syntax, so that's got to be there no matter what. And then I have to specify the list that I'm going through, or the variable that I'm going through, and I know from my definition that that variable's name is text. So this loop right here, and then I've got the colon again too, is going to go through the entire string letter by letter by letter. Now what I have to do is I have to make sure that it's only printing out the correct letters. So I'm going to do another indent. I'm going to say if letter, because again, that variable has the current letter that I'm looking at, is in, and then inside of quotes, I'm just going to put an uppercase s and a lowercase s, because those are separate characters and I have to specify both of them. All right? I'm going to have my colon, and then I'm going to indent again to say that I'm only printing them out if this statement is true. So I'm going to print letter. All right, so that's going to go through the word one letter at a time. It's going to check to see if there's an uppercase s or a lowercase s, and if there are, it's going to print it out. If they're not, it's not going to do anything. All right, so that would meet the requirements of this description up here. All right, let's take a look at the second one here. This says complete the function count s's text below that takes as an input a string called text and returns a count of the number of occurrences of the letter s, either upper or lowercase. For example, if text is she's selling seashells, the function should return 6. All right, so a lot of ways it's going to be very similar to what we just did, only instead of printing things out, we're just counting the letters s. All right, so I would encourage you to pause this, give it a try, and then unpause it, and you'll hear me kind of explain and go through it. But it's very similar to what we just did. All right, here we go. So here's my loop. The loop can look basically exactly the same as the one above, because we're still going through one letter at a time. Okay, so that part looks exactly the same. I'm still looking for s's, so that part looks exactly the same. If letter in uppercase s, lowercase s. All right, so no difference there. The only difference is I'm no longer printing. All right. Instead, I'm going to be changing my variable. So I can say count equals count plus 1. All right. I'm just keeping track of how many S's there are and increasing that count. And then when the function is over, or sorry, when the loop is over, because notice this return statement is at the same level as the for loop. So after I've finished going through the whole word, then I'm going to return the count and send back that answer. All right. So very similar to this top one, just we're doing something slightly different inside of the if statement. All right. Collecting characters into strings. Okay, so before we move on to the next big topic, I just want to talk about collecting characters into strings, or put another way, like building a string letter by letter by letter. All right, so here we start off with the word All right, so we've got a string variable storing in it. All right, if you want to start building strings letter by letter by letter, all right, this is the syntax that we generally use. We say word equals word, so it equals whatever it used to be plus whatever character we want to add to it. So when we say word equals word plus m, we're taking this m, we're sticking it on the end of this, and if we printed it out, it would be with two m's. If we do it again, word equals word plus m, now we're taking this version, we're adding an m to it, and we end up with If we do it again, we're adding another m to it, and now we're getting with 4 m's. So by doing this word equals word plus whatever, we can slowly build up the string and keep extending it and adding to it as we go. And that's going to become relevant in the next few slides when we start to use that for different things. But I just wanted to kind of make this clear and kind of show it real quick here. So generally, remember, when you're doing these equal signs, we evaluate the right hand side and store it in the variable on the left. So you can't flip those around. You always have to have the addition on the right side, the variable on the left side, and then we evaluate this addition or this combining of strings and store it in the left-hand side. And again, that's going to become really relevant in the next few slides because we're going to use it to sort of build different things. All right, so what we have here is another task. And it says, write a function that takes as input a string W and returns a new string consisting of just the values in W. All right, so first things first, it says returns. So I just want to circle that and remind you that returning is different than printing. So we're not printing in this case. We're going to be returning a string variable. All right, so this returns the string W. So it's going to return just the vowels. So if this was our original string, it's going to return just I, O, I, and E. All right, so let's see how we're going to make this happen. So here we have a variable called result. And when we just do quotes next to each other, this is how we define an empty string. So at the very beginning, this is eventually what we're going to return. This is the variable we're going to send back. At the very beginning, this variable is empty. And then our goal is going to be to slowly add the vowels to this variable until we eventually arrive at our solution. So how are we going to do this? Pretty much what we've been doing. All right, we're going to go through this letter by letter. We're going to look for vowels, and when we find them, we're going to add them to this one variable. All right, so we're going to start with our for loop. We're going to say for, and then again, this is the loop variable, so it can be whatever you want, but letter's been working pretty well for us, so I'm going to keep using it. In, now it's the name of our list or our string that we're going through. That's W, all right? That's what it was defined in the function, so we're going to go for letter in W. Then we have our colon. Now we're going to check to see if it's a vowel. So we're going to say if letter in, and then we want to make sure that we're getting both the uppercase and the lowercase vowels. So we're going to go A, E, I, O, U, and then we're going to go uppercase A, uppercase E, uppercase I, uppercase O, uppercase U, because again, those are different and it treats them as different. So we have to make sure that we're looking for both of those. Then I can have my colon there. And then this is the part that's a little different than what we've been doing so far, but this is where we're going to build our string. So we're going to say result equals result plus whatever letter we're currently looking at inside of the string. All right, so it's going to take the previous state of the variable result, and it's going to tack our letter variable onto the end of that. It's going to squish it onto the end, and we're going to get one string at the very end of this. Now, when this loop is done, this variable should have our final string inside of it. So we're going to have our return statement, and it's very important that we bring our return statement all the way over to the left, because when a function hits a return statement, that's it. All right. Once it hits the return statement, the function ends. So if we put the return statement inside of the loop, we won't actually go through the entire string. We need it outside of the loop all the way to the left so that the loop is allowed to finish. And then we're going to return the result. All right. But I just going to emphasize again, this is outside the loop. All right, because if it's inside the loop, your program's not going to work properly. All right. So when this finally ends, we should, in theory, have a string that's made up of a lowercase I, a second lowercase I, an uppercase O, a lowercase I, and then an uppercase E. So I-O-I-E. All right. But I do want to take a second to go through this slower. So we're going to trace this function, which means kind of walk through it when W equals, and we're just going to use a shorter one. All right, so I'm going to make it bean like this. Okay. So we've pretty much got two variables that are going on here. We've got the variable letter, and we've got the variable result. Now, at the very beginning of our program, result is empty. We then enter the loop, and the letter that we're looking at is B. Right? Sorry, uppercase B is a B. That is not a variable, so I'm sorry, it's not a vowel, so result is going to stay empty. All right, next we move on to an E. E is part of our list up here, so it gets added to our result, and we get that. Right? Then we move down, and we get to the uppercase A, which is also in our list. So it gets added to our result, and now we have E uppercase A. Then finally, this moves on to an N. N is not part of our list, so result stays the same. We've reached the end of the string, so then and this gets returned. Because we reached the end of the string. And again, this is just showing us the current state of the variables. And so just another example of a loop, and then just showing something different that you can do inside of these if statements. All right, you could build strings according to some rule or condition that you've specified. And we build the strings with this result equals result plus whatever you're doing. It's kind of syntax there. All right. So continuing on, what if we want to jump to a certain part of the string? Or what if we don't want to go through the entire string letter by letter? Right? Well, it turns out we have another option. All right, and this other option is called string indexing. All right, and this is going to allow us a little more flexibility with how we proceed through the string. So when you have a string is really just a bunch of characters stuck together, and we can identify each of those characters. All right, so the string Happy New Year is really the character capital H, which we say is in index 0 or spot 0. The letter A, which is in spot 1, P, 2, 3, P3, and so on and so forth. Each character in the string gets an index number, which is basically its location in the string. Now, the indexes start at 0, and they stop at the last character. So this goes from 0 to 14, which remember, if it's going from 0 to 14, that tells us that in total there are 15 characters in spots 0 to 14, right? And we saw this same sort of thing with pictures. If a picture was 100 pixels wide, those pixels were in spots 0 to 99. Same exact idea with the strings. If the string is 15 characters long, they are in spots 0 to 14. All right, so let's take a look at this. So if we've got the phrase Happy New Year, and we say print phrase, and then notice the syntax. These are square brackets. They are not parentheses. They are not curly braces. They are square brackets. This is how we can access an individual character. So this right here would print out an uppercase H because uppercase H is in spot 0. All right, this right here would print out a lowercase a because it's in spot 1. Right? If we wanted to jump to spot 6, that would bring us over here, and we would get an uppercase N. So we can now access different parts of the string. We don't have to look at it as one big thing. We can access the individual elements of it. Now, we said print length of phrase. Remember, this is going to get you the length of the string. So even though they're numbered from 0 to 14, that means that there are 15 characters in total. Now, if you wanted to know where the last character was, right, it's going to be length of phrase minus 1. This will always give you the last character. All right, and again, I'm bringing it back to pictures. If a picture is 100 wide, the last X value is 99. If the string is 15 long, the last character is in spot 14 because we're starting at a 0 there. So if we were to print, or sorry, if num equals length of phrase minus 1, this is effectively doing 15 minus 1. So when we print num, we're really printing spot 14, which is the last spot, which is our exclamation point. All right. If you print phrase 18, that's actually going to give you an error. All right, so this is going to give you an error. The index 18 is too large. All right, so that's not going to work. Now, something that's interesting about Python is they actually, and almost no other language does this, but it actually also allows you to do negative indexes. So if you put in an index of -1, all right, that's the same as putting in an index of 14. That'll give you the exclamation point. This would be -2, -3, -4, -5, -6, -7, -8, -9, -10, -11, -12, -13, -14, -15, and then -16 would give you an error. So Python's a little unique in that negative indexes will actually work through the string backwards. But that's something I wouldn't get in the habit of using that because no other language that I'm familiar with, and again, I'm not familiar with all of them, but like Java, C++, JavaScript, things like that, they don't support this negative indexing. But it does in Python. If we typed in a phrase of -1, it would give us the exclamation point. If we did phrase brackets -11, it would give us the Y. So it does support negative indexing, but I wouldn't use it very often. It's pretty rare, at least with the languages I'm familiar with, but I'm not familiar with everything, so who knows? All right, next, I want you to try some of this indexing stuff. All right, so I want you to try some of this on your own. Pause the video, and then I'll come back and walk you through it to make sure you got the right answers. All right, so A equals go team. If we print out A sub 0, all right, 0 is the very first character, so that's going to give you an uppercase G. 1, actually, why don't do it this way? I'm going to just put the indexes above. So this is index 0, 1. Don't forget the space is index 2, 3, 4, 5, 6, and 7. All right, so index 1 is going to be a lowercase o. If I do index 0 plus index 1, that's just going to give me go. All right, if I say num equals length of A, well, length of A is the length of the string, and even though it's numbered from 0 to 7, that means that this is going to produce an 8. So when I print num, I'm going to get the value 8. And if I say print num minus 2, I'm saying print 8 minus 2, or print 6. So this is going to give me index 6. This is going to give me index 7. Or put another way, it's going to give me the last 2 letters, which is M exclamation point. All right. Now, here we have num double division, remember, is integer division, which is another way of saying no decimals. Now, the reason we're doing that is because you can't have a decimal index. All right. Let me just put that over there. You can't have a decimal index. So we don't want to use regular division because if it was an odd length, you could end up with a decimal and then you get an error because you try to put a decimal index into here. But by doing the double division, we know that it's going to drop any decimals. Now, again, on this one, the length is 8, so there wouldn't be a decimal anyways. So it's just going to be 4, which is going to work fine. But if you're doing this sort of thing, like trying to get to the middle of a string, you always want to use the double division so that you don't get a decimal, because a decimal could cause an error that would cause your program to crash. So we're dividing by 2, we're getting this 4, we're printing out index 4, which is the letter E. All right. So hopefully those went pretty well for you. Again, it's just kind of getting familiar and getting comfortable with the idea that the first one is in 0, and the last one is 1 less than the length of the string. All right, those are the two kind of key things that you want to remember and keep straight in your head, because those are the two things that tend to goof kids up the most. All right, so taking strings apart. All right, complete the function below that returns a string consisting of the first 2 letters of the input string. Example, first 2 of Ichabod Crane should return I see. All right, so our string is being stored in the letter S. So I could start with a variable result. All right, and I could have it empty at the start. And I could say result equals S of 0, because that's going to be my first character, plus S of 1, because that's going to be my second character. And then I can say return result. Now, a couple of things here. I went through each step just to be really explicit about it, but you could have actually just started with this and said result equals S sub 0 plus S sub 1, and that would have been fine. And you actually could have just done return this calculation. All right, so I didn't even need to technically make a variable. I could have just said return S of 0 plus S of 1, and that would have worked as well. But I think early on it's sometimes helpful to go through each individual step. All right, complete the function below that returns a string consisting of the first 2 letters of the input string followed by the last 2 letters. Example, first, last 2 for Ichabod Crane would be ICNI. All right, so similar to what we just did, I am going to shortcut it a little bit this time. All right, I'm going to make a variable called first. And instead of setting it equal to the empty string, I'm just going to jump ahead and do this part because it is exactly the same as the last part. All right, so that's the first part of our string. Then I'm going to make a variable for the last part of our string. And this one's a little trickier. All right, this is where we're going to use that length function. Now remember, if I do the length on Ichabod Crane, 3, 4, 5, 6, 7, 8, 9, 10, 11. It is going to tell me that it is 12 characters long, which is correct, but I have to remember that the last 2 characters are actually in spots 10 and 11. So the way I'm going to get those is I'm going to say S of, or index of, and then I'm going to do the length of S, which is going to be 12, but then I'm going to subtract 2 from that, which will bring me back to index 10 and get me the letter N. And then I'm going to add to that the final letter, which I'm going to get by doing S length of S, and instead of subtracting 2, only subtracting 1. Now, I could make a new variable to combine first and last. I could say first equals first plus last. Or I can jump start that, and I can just say return, if I spell it correctly, return first plus last. All right, so I can return a whole concatenation or addition here. I can return this as one item. Now, again, I could have also have done first equals first plus last and then returned first. That would have worked. I could have also done result equals first plus last and then returned result. Either one of those would have worked, but I'm just going to skip right to it on this one instead of kind of going through those extra steps. All right, so can I use this indexing to mimic what we were doing earlier? All right, and just a reminder, this is what we were doing earlier. All right, we were setting up these loops where we said 4-letter in string, and it would go through the entire string 1 letter at a time. Can I use indexing to mimic that? All right, and the answer is yes. All right, so what I can do is I can say for index, and again, this is just my loop variable, so this could have been called whatever I wanted. This is my name for it. In range of 0, right? Because that's going to be where the first letter is. So this is going to give me the first letter. And then I can say to length of string. And you might be saying to yourself, well, why length of string? Why not length of string minus 1? All right. And we have to remember that when you do range of, let's just say 0, 5, this goes back to when we first learned about for loops. 0, 5 will only give you 0, 1, 2, 3, and 4. All right, it doesn't actually get to that last value. So when we say 0 to length of string, it stops short of the length. All right, this will bring us to the last character because that last number that's part of our range, we never actually get to. So that works perfect for us because we can just say length of string. We don't have to modify it because the loop will stop 1 short of that number, which is where our last letter actually exists. So what's the difference between this and this? All right, here's the main difference. All right, with this loop, this variable does not have a letter in it. All right, this variable has a number in it. All right, it starts with the number 0, then it goes to number 1, 2, 3, 4, and so on and so forth. That number gets fed into these brackets to get the individual characters. All right, so this is a number, not a letter. All right, and that number gets fed in so that we can see the individual letters. Here, this variable actually has the letter in it. All right, it is not a number, it is the actual character that is part of the string. So you just have to keep these two straight because depending on which one you're using, this loop variable is going to have something different inside of it. All right, and we saw the same thing with pictures. All right, the very first loop we did with pictures, it was for each pixel in, and we used that get pixels function. There, the loop variable was the pixel. Then as we got a little further and we started doing x's and y's, the loop variables became coordinates, and then we had to use those coordinates to retrieve the pixels. Same exact idea here. All right, this is the actual letter, which is the equivalent to it being the actual pixel from the pictures. This is a number that we use to access the letter, which is the same thing we were doing when we had xy coordinates. All right, so let's trace through one here and just kind of make it clear what's happening. So if we were to call this function with the word bear, all right, the index would start at 0, and the output that we'd actually print out would be the letter B. Then the index, which is our loop variable, would change to 1, and we'd print out the letter E. Then the index would change to the number 2. We'd print out the letter A. The index would change to the number 3, and we'd print out the letter R. So the length was 4. So we were going from 0 to comma 4. But when you go from 0 to comma 4, it only actually produces 0, 1, 2, and 3. All right, so it works exactly how we need it to work to run through the entire word. All right, so again, both of these loops, this loop and the one from before, goes through the entire string. They just do it in slightly different ways. Now, the advantage here is that sometimes we might not want to go through the entire string. So we can change this value and start at a different spot in the string. we can change this value and end in a different spot in the string. Whereas this one, we're kind of locked into always doing the whole string. So this one's less flexible. It's a little easier, but it's less flexible. This one requires a little more work and a little more setup, but it gives us more control over what we're doing. All right, so we've got one more problem here that we're going to look at, and then you're going to get to practice some of this stuff on your own. All right, so it says complete the function below that returns a new string that is the reverse of the input string. Your program should use indexing. So, for example, if we send reverse the word hello, it's going to spit back OLLEH. All right, so that's kind of what we're trying to accomplish here. Now, this is some place where indexing is going to be really valuable because indexing is going to let us work through the word backwards. All right, and normally with that other for each letter in string that we've been using, that forces you to just go through the letters one by one in order. With indexing, we're going to be able to set it up so that it goes backwards. Now, before we can do that, let's just review the range function for a second. So the range function normally has a starting point and an ending point, and then you can stop there. All right. If you stop there and only provide a starting and an ending point, it will automatically count up by 1. But you don't have to count up by 1. You can provide what's called a step value. All right, and that value can be whatever you want. It could be a positive number. We could count up by 5s or 2s or 3s, or it could be a negative number, which would allow us to count down. So again, the default is 1. So if you leave this step part out, you're going to go up by 1. But if you specify it, you can start going in different directions and you can start going by different amounts. And that's what we're going to take advantage of here. And this is something that, is only possible through use of the indexing method. All right. Again, this loop here wouldn't cut it because this loop only goes through it letter by letter in order. All right. So we're going to start with our empty string. So I'm going to start by saying result equals, and then I'm just going to have quotes, and I'm not putting a space in there. I'm literally just putting the quotes right next to each other. This is my empty string. Then what I'm going to do is I'm going to set up a loop that's going to work backwards through the string. So I'm going to say for, because that's the required part. I'm going to call my loop variable the index. And again, that could have been what I wanted. In, that's a required part. And then I'm going to set my range. All right. And that's where we're going to take advantage of this step. So we're going to start our range at the end of the string. Now, with this example, hello here, 0, 1, 2, 3, 4. My string ends with index 4. But I don't want to hard code a 4 in here because then it would only work for the word hello. So what I'm going to do is I'm going to say it starts at the length of the string. Now, the length of the string would actually be 5. So I'm going to say it starts at the length of the string minus 1. All right, so that's where it starts. My range is going to start at the length of the string minus 1, which for the example of hello would be 4. Now, you might be saying to yourself, all right, well, I want it to stop at 0, so I'm going to put a 0 here. Not quite. All right, remember that when you do a range, let's just pretend I'm doing a range from 0 to 4, you get 0. I don't know why I did square brackets there. You get 0, 1, 2, and 3. So if I want to stop at 0, I actually need to go all the way down to -1. Right? Because if I go down to -1, I'll get the 0 that I'm looking for. And then I'm going to provide the step. This is the part that's different. This is the part that normally we don't use, but I'm going to provide a step of -1. All right, this is telling it to count down by 1 instead of counting up by 1. So again, let me just do like a silly example here, but if I said a range of 5, comma 1, comma -1, this would give me 5, 4, 3, and 2. All right, it doesn't get to that last value, which again is why we had to go to -1, so that we'll get, in this case, 4, 3, 2, 1, 0. All right, but this new part here is the step, and that's going to allow us to count backwards. All right, so once we've set this up, let's not forget our colons at the end there. Once we've set this up, the inner part of the loop is going to look pretty similar. It's going to be result equals result. So we're going to build the string one character at a time. And then we're going to use those indexes. So our variable is called string. So it's going to be plus string. And then I'm going to put in that index number. Because remember, when we use indexing, this variable is not the individual letters, it's the numbers. So it's the number 4, it's the number 3, it's the number 2, it's the number 1, it's the number 0. And that's going to slowly build my string. Now, once the loop is over, all right, so I'm no longer indented, I can then say return result. All right, so again, if we were to kind of trace this and think about what's happening, all right, you've got your result variable and you have your index, your index variable. So at the very start, result is empty. And then if we're sending it the word hello, all right, our first index variable is going to be the length of that string, which is 5 minus 1. So it's going to give us an index number of 4, which gives us the letter O. Then, since we're counting down by 1, the index is going to become 3. We're going to add the L to that O, and we're going to end up with OL. Then the index is going to become 2, and we're going to get OLL. Then the index is going to become 1, and we're going to get OLLE. Then the index is going to become 0. We're going to get OLLEH. And at this point, the loop is going to stop. All right, the loop is not going to continue at this point because remember, it doesn't actually get to -1. It stops 1 short. So this would be the value that gets returned. All right, so we can see here that setting up and using indexing gives us a lot more control than we can get with just the traditional for each letter and string loop, right? That just doesn't do as much for us. So what's up next? All right, what's up next is that you get to practice some of this stuff. All right, so you're going to practice writing some of this code, and it'll all be set up on Classroom for you to do. But there's 4 exercises. The first one says, and they all use string indexing. So they're all going to use the indexing method that we just talked about. All right, so implement the function first half below that returns a string consisting of the first half of the letters in the input string. You may truncate the decimal when the word has an odd length. So if the word has an odd length, the decimal just gets cut off and you don't have to worry about it. Use string indexing. So again, you're going to set up something very similar to what we just did here, except your range is only going to be going through half the word. All right, so you're going to have to modify this range so that you can start at the beginning, so you don't have to do this whole backwards piece, but you only want to go to sort of the halfway point of the word. All right. This one says you are writing a 5-page paper for the school, but you only have 4.5 pages. You're going to write a function that basically adds a space after each character. So you're going to go through the entire word and add a space after each character. So again, here's a loop using indexing that goes through the entire word, and then you just have to build a new word that has a space after each character. This one takes 2 inputs, so it kind of allows you to customize things. And then you provide a number, and then the function returns the last X number of numbers. So if you put in 4, it gives you the last 4 characters. If you put in 7, it gives you the last 7 characters. But you're creating a function that has 2 inputs, a string and a number, and that number is telling you how many of the final characters you get. And then last but not least, you're going to write a function that returns a string consisting of every other letter. So if hello is passed in, you're just going to get every other letter. If Mississippi gets passed in, you're going to get every other letter in that word. And for example, it's just a reminder of this range function that we have in Python. That's the starting point, that's the ending point, but that's the step. So you don't have to go up by 1. You don't have to go up by 2. Sorry, you don't have to go down by 1. You could go up by 2. You could go up by 3. You could go up by 4. So this should help you figure out the code that you need to write so that you get every other letter. All right, so this is the practice that you're going to do based off kind of everything we just talked about. All right, good luck, and I will see you when I see you.